just make sure the construction line is not selected on that side. Yep, and then do that. And then
Do you need help in the back, Tim? Yeah.
so you have the wall, so then you create a sketch on that plane. You'll just select that specific. So if you rotate, you can probably get a better view. And then just, you want to select like the plane specifically myself. Yep. Upside down. If you go up here to the cube and hover, you'll see those like two curved arrow keys on the top right corner. And then you just rotate them like that. Yep. And then you'll project that base right there. And you just click on the whatever you want to project, so that rectangle will be where you want to go. Yep. And then make sure it's construction line type. So the line type right there on the side of me. Yep, it's the first like line type, so it's like a triangle within there. I don't know if it's a triangle line type right there. No, on the side of that. Yep, so one over. Yes, that. Now it's construction lines. So they're not going to show up in the title structure. Okay. Now you just want to draw a rectangle, snap into this. You just make a 2-point rectangle. I would just put it like in the middle. And then just make sure it's not construction line type. Before you go, you want this to actually show your sketch. You'll just unclick construction. And then you want it snapped onto like the base. So the top line right there. And we'll explain why in a bit. Like zoom in a bit on the track right. That top line. So there's somewhere random on that top line right there. And then you just drag it up like you have it. It can be anything.
Okay, so now that we have that, we're going to go ahead and dimension the height. So I'll use the right edge. We'll use sketch dimension. We'll click on that right edge. And we'll make the height 4 inches. Oops. Ignore me clicking on the sketch dimension line at 4 inches. That's going to make us a rather tall wall. And then we need to dimension the width. Before, like we've done, you could dimension, the actual width of this. But instead, I'm going to dimension it. Oh, yeah. We just added a dimension on this line that is 4 inches tall. So you just hit sketch dimension with that edge, drag that out. You're good. Is everybody good here? Okay. So we're going to dimension these two lines relative to the edge of the base plate. So I'm going to select the edge of the base plate, which should be construction line there. And then I will select this line of our wall. And that's going to give us this dimension, showing you the distance from that line to the edge of the wall. We'll put that in, and we'll make that 40 millimeters, or 40 millimeters, not 4. And we'll do the same thing on the other side. Before you do that, because I did that, it shifted the whole thing over. You notice that, at least for me, it might be different than how you do yours. This edge is all the way over here. We'll just drag that in before we do the dimension, because if you don't do that, it's going to think you're dimensioning it this way and not the way that we want to actually do it. So just make sure, in general, before you mention things are on the correct side of each other that you want them after the dimension. But I'll select this line. I'll select the edge of the wall, make that 40 millimeters as well.
Did you want to switch around halfway through, or did you want to keep going? It's up to you.
Okay, I think that is right. And so now you see we have a wall that is 4 inches tall and is 40 millimeters in from each side of the base plate. Was everybody able to make it here? Okay. Now, if I wanted to know right now if this sketch is fully constrained, how can I find that out?
So, so you execute the
Wait,
sketch.
wait.
That's it, yeah. So you go to the timeline and then click on sketch. And you should go down to sketches down the left and you see the
Yeah, we'll open the component, we'll open sketches, and there is a lock there. So we do have everything fully constrained.
Yeah, so, can you just control Z real quick? Yeah, so, what you're saying is that when it's past here, if you wanted it to be dimensions like this direction, it's gonna dimension it going this way, so if you delete that dimension and drag it in, and then it will dimension approximately instead. Okay, so, you just control Z because you have dimension. Yep, and then you can drag that line. The blue line, you can drag it. And if it's not, and then you dimension it. Because then that way it's this side, not that way. Press D. So we have the tools, so then we'll select two things on dimension. So we'll do the height, so we'll the bottom to the top piece. We'll click on the bottom line. Yep. And then the top line. Yep. Run the height. And then we can just, the second click is just placing it, so there's an arrow you can place it. Just place it. Yep. Just click it. Yeah, you just click it somewhere, like where it's not aligned. I would put it like near the line, because you won't be able to click it without. Yeah, just anywhere you can access it, and then you type in what you want. What was the height of it?
Height is 4 inches.
4 inches. And then you want the wall to be 40 millimeters from the outside of the piece. So if you want this wall to be 40 millimeters from the edge, you'll dimension the wall so like that fits. Yep, so you select that side. Okay, so that way. And then you select like the point on there. Because you want the wall open. So right now you just make sure you actually click the point down. Yep, go. And then that's your placement. Yeah, we need to go around. And then go forward. And then you do the same thing for the other side. And now make it so the wall is always 40 millimeters for the outer edge of this. You're letting you click up once and you haven't clicked something else, it's thinking you're just trying to change the height of that wall. It's telling you it's so constrained because the height's already been set by another dimension. So you might want to hand over and zoom out so you can see the other side. Yep.
I'm good, right? Okay. So now that we're back in here, again, just to review, we've had mentioned the two sides and we've mentioned the height. Because these two sides are constrained, the width is inherently constrained. And I'll show you something that you can kind of show back there, you guys can get to see. If I try to dimension this whole width and then click that, it's going to tell me that it's over constrained. That's because these two dimensions, because they both exist, the width of the whole thing is already defined. If you ever get that, always just click cancel. There's an option there for driven. Don't click it. That's advanced stuff. Just always cancel. It just means you did something wrong. You need to look at how your dimensions are. And then I asked, how could we tell us if the sketch is fully constrained? And you answered up here that if we just open the component and we open sketches, we'll see we have a lock here. So we know that we're good to go. We are fully constrained.
And real quick, just like a note for constraining, there's technically no right way to do it in that, like, there's multiple ways to constrain the same line. So if you wanted to change like the distance between two walls, you could select both walls and then set the distance, or you could just select the line in between them, set the distance. There's a variety of different ways you constrain. Like you could select the outer wall and that point, or you could select the outer wall and the outer wall of the base. There's multiple different ways you can constrain something.
Yeah.
Just matters it's constrained.
As long as it gets constrained, that's what matters, not so much how you do it. And honestly, how you do it just ends up being personal preference and also what you're making. Okay, so now we're gonna add tabs. If you remember from all of our other hovercraft lessons, and the PowerPoints we're showing you, there you have a wall, you have a base plate, and the way that it goes into that base plate is from tabs.
So this is your wall. That's a nice little tab too. And this would be your base plate. I already marked it, but you get, yeah, you get.
Yeah, so again, this base plate is like, it's into the board if you imagine it, you're looking at it from the side. And so that piece is gonna go down. So we'll go ahead and make some tabs. We'll use a 2-point rectangle, top left, to make that. I will go ahead and put one right here. So make sure that you're actually snapping. When you're snapping to 2 lines like this, you'll get a little X, but it's the same thing as the square we've been talking about before. It just means you snap. So we'll snap one corner to the bottom edge of that. We'll snap the other corner, or the other corner of the rectangle down here at the bottom. Don't matter about dimensions yet. Just make sure that top edge is, the top corner is snapped and the bottom right corner is snapped. Okay, then we'll do that again and we'll put one on the other side, sort of like this, so that we have 2 rectangles. And then we're gonna go ahead and dimension these. So let's first dimension the width. And this is something, like people were saying before, there's multiple ways to dimension the same thing. So I could just dimension this edge here. Well, let's say I want this to be 30 millimeters. I could do that. I could also instead dimension the distance between these 2 lines, like by clicking one then the other, and put the dimension there. Okay, I gotta go with this first, my bad. But you would click the distance between these 2, and I can type in 30 there, and that does the exact same thing. There's multiple ways to dimension the same piece. So let's go ahead and dimension this to be 10 millimeters wide. And I'll dimension the distance between this line and this edge over here. And by clicking that one first, the second edge second, and then just place the dimension down here. We'll also make that 10 millimeters. Let's do the same thing on the other side. So make the width of the other tab 10 millimeters. And then the width of, or the distance from the edge to the edge of the base plate, also 10 millimeters. Everybody's good.
You guys all got that?
Okay. Last thing we want to do is to trim a little bit. Right now, these are different shapes, which is not necessarily a problem. You can still extrude it like that. It just, especially when you have more complicated sketches, if you trim along the way, it makes your extrude step a little bit easier. So we'll click on the trim tool up here, and then we'll go ahead and click on the line in here. You may have to click it twice, because there's technically 2 lines there, right? There's the first line from the box and then the line at the base plate underneath it, and that will get rid of the line. You may get a warning that constraints were removed. That's okay. Our sketch is still fully constrained. It's just telling you that because the line is split, it removed one of the constraints. And what we should see now is that this is all one piece. If I click on it, you'll see it's highlighting the whole thing.
Yeah.
Versus before, you don't have to undo. I'm just doing this to show you. If this piece is just this top piece. So.
Yeah, very well. Just like that. And you just dimension it from the outer edge.
So are we fully constrained up here? Is our sketch good? Yes, and because you know that because we have a lock up here.
We already have the distance, so now you want the distance from the outer
Oh,
edge.
wait, back there.
This wall to here, right? Yeah. So that's how. And you can just take that and move the wall. Yes. exact same thing on the other side. Richard, you can do math.
What?
Math.
About what? Oh, yeah. I think we get there. It's something else in there.
Is it?
Oh, actually, it's not. You're right. Okay, this I'll show you. One other thing about dimensioning, you don't need to follow what I'm doing. But let's say I have this line here, and for whatever reason, I know that this needs to be 17 times 3 millimeters. Instead of getting out a calculator and doing that separately, you can just type in 17 star 3 and press enter, and there you go. You have the full dimension. And again, if you edit that, it has originally been typed in. I mean, it adds parentheses and millimeters to it, but it is originally the thing you typed in. It doesn't like convert the number. So that's, especially when you have more complicated geometries that require math like that, it's just something useful to know. You don't need to do the math externally, just type it in and it will calculate it for you. Okay, so now that we have everything is fully constrained, we'll go ahead and press finish sketch. We'll come back out here. You can see our sketch sort of in a 3D view, but it's still 2D. We're gonna go ahead and extrude that.
Yeah, point. Or you could select the wall. You can point there for the wall. Either way. It's part of that rectangle. Yeah, you click on the yeah, so click on that one again. Yeah, so you already clicked on that one. And then click on that one. Yep. The second time you click on it, you unselect it. Yeah, so yeah, you unselect the line. There you go. Just click on it. No, yeah, so the point was already selected. It doesn't unclick it in there. It's just when you click a point, it removes it. Right? There you go. And then we just want to clean up the lines of the pad that each of these two pieces, right? Because this one's solid piece. So there's the trim tool right here, as I see. And then if you just click that line there between. So select the line. Yep. 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 And you'll do it right there. Yep. So it like cuts that out, so it's not one solid piece, right? So then you'll finish your sketch. And now we're here.
Okay, so we have this now in 3D. We're gonna extrude it. So click extrude in the top left. Under the crate section, we'll go ahead and extrude this. This is one of our wooden pieces. So how thick are we gonna make this extrusion? Anybody? 5 millimeters. Thank you. Let's go ahead and type in 5 millimeters. And then press enter. And we have our little 5 millimeter thick wall with 2 pegs at the bottom. Now just to see everything, I'll go ahead and activate the whole project by hovering over here and hit activate component. That'll make everything solid for us. So now I have this question. Well, first of all, is everybody here? Is everybody able to get to this point? Everybody good? Okay. Let's say could I right now with this design, walk on over to the TI lab, hand them these files, assuming that it's already printed in the laser cutter format. Could I go cut this, get these pieces, and assemble them right now? No, what's the problem with it?
There's no hole.
Yeah, there's no holes. Yep. If I hide that, this is a solid piece. I would just be stabbing into nothing. So we need to add the holes into the base plate. And this is probably one of the most counterintuitive things that has to do with the way they named the tools. It'll make more sense once we do it. But in order to add the holes to this base plate, we're going to use the combine tool. I'm aware that it sounds confusing, but it makes more sense once you use it. So we'll go ahead and click combine. The target body is going to be the body that we're going to try to modify. So over here, it should already prompt you to select target body because it's blue. We'll select the base plate as the target body. Now it's moved on to tool bodies. Tool bodies is the body that you're using to make the modification. The target body is what we're changing. The tool body is what we're using to make the modification. We're going to use this body to make the modification. Then the next one is operation. They have join, cut, and intersect. We're going to do cut, and just like everything else in 360, you can hover over it and after a little bit, it'll give you a better description of what it's gonna do. We're gonna do cut. And then the last piece is keep tools. If you don't check keep tools, it assumes that the body you selected for tool body, you only made that body for the purpose of using the combine tool. And that's the default, because that is a common thing you do. And so when you finish combine, it does it, and then it deletes the tool body. So in our case, you do want to select keep tools. So you should see this, bottom being blue, the top one being red, telling you that you're cutting it away, and then press OK. And then it looks like not much has changed, but if we hide the wall now, we have 2 holes in our base plate.
So we're going to modify it, okay? And it should be the combined tool. In the drop down here. And it will do automatically because you had it. So
Everybody else able to get here?
It's hard to do what I want to have basically.
Is it for the
tool body select?
filter project?
And you're gonna select where we want to have it.
I'm really interested in.
We'll talk about that in 1 second.
And then we want to change the operation to cut, because right now it's in combine.
When you guys were doing that, what was it? Was it 3D printing or?
No, this is laser cutting.
It was laser cutting. What, out of what materials?
That's really important. If you don't like it, we'll just remove
They had you offset for that?
I don't know if we did or not.
And you should have cut the holes.
I'm not, I don't know.
So they'll show you.
Okay, was that something they told you, or you guys just did it?
They like suggested it, but they said if we don't, it's probably fine.
Okay, well, I'll get into that, maybe when I explain it, it'll make more sense.
What they say?
I can tell you it. Anyway, so yeah, now we have our hole in there, and we're chilling. Notice we have quite a few things in our timeline here. Something I want to point out is because we did a good job of constraining everything along the way, let's say we go all the way back to our very first sketch. You don't have to follow along if I'm doing this, but you can. I'm going to go all the way back here. And let's say, actually, I lied. I don't want it to be 6 inches wide. I want it to be 10 inches wide. I can go ahead and make that change and press finish sketch, and everything else is going to change along with it. Now, the width of the wall has changed as well, because we originally defined it to be relative to this edge, right? Also, if I hide this, the positions of the 2 holes have changed. Because along the way, we did a good job of constraining everything properly, if we go back and change some critical dimension in the timeline, everything else just updates on its own. We don't have to go back fixing a million things. If you didn't, then you probably would have to go back fixing a million things. So that's just, try and stay on top of making sure that you have, that you're dimensioning things along the way.
You want every single sketch you ever make should have the red lock on it when you're done. If it has a pencil, there's something unconstrained, and you'll have to hunt that down. They should all have red locks. And sometimes unconstrained things could literally be like a point. So some random point on like a rectangle or some shape could be unconstrained. So you'll literally have to go around and just grab points and try to move them. And if they move, they're unconstrained. So
Yeah, and that was something as you guys CAD will show you techniques to find unconstrained things. But that is sort of a situational thing when you guys start CADing. So yeah. One other thing I want to show you, which is not something that is in the way that we made this, but when we were doing this, we were sort of explicitly making new components like this. There is kind of a shortcut, but you just want to be careful with it to make sure you do it. Because if you don't do it when you make it, you can't do it later. Let's say I am making a square here. I'm going to press finish even though I'm not constrained, just for the example purpose. Don't actually ever do that. Make sure you constrain things. But if I go to extrude, in here, the default's to new body. You can actually change that to new component and then just press OK. And that automatically makes you a new component with the new body inside of it. That is sort of just a time-saving trick. The key thing to note, though, is you have to do that the first time you extrude. If I go back and try to edit this extrusion, new component's gone. So if you make that mistake and it wasn't a component then, you will fix it by reorganizing. And again, that'll be something we'll help you out with when that happens. But yeah. Any other major things?
yeah, so there's a lot of tools we didn't directly show here. If you sort through the modify and create menus, they're all pretty self-explanatory. If you just hover over them, you're not going to have to use a lot of them for hovercrafts because they're working sort of in 2D. But if you make a 3D printed piece, or if you're doing a different CAD project, you will probably end up having to use them. So I definitely go through and read them. And for the sketches, the sketch menu has a lot of different options of different shapes. So I'd recommend reading through all those, seeing what you need. But this is just the basics. This is basically your entire hovercraft right here. This is almost competition ready. Basically, good to go.
So now, last thing I want to explain is a bit about manufacturing, which I think we actually get more into next week, but you asked, so I might as well bring it up now. What?
I was going to mention it
Oh,
earlier.
go ahead. Go for it.
There we go.
What is that?
Additive and subtractive, man.
Oh, okay. So yeah, so there's different types of manufacturing methods.
Is that what you're gonna mention?
Yeah, that's what I didn't know what you were drawing. So there's different types of manufacturing methods. The main two are being additive forms of manufacturing and subtractive forms of manufacturing. Most common form of additive manufacturing is 3D printing. It means you're adding material to the piece of work to make a bigger thing. And then subtractive manufacturing is honestly mostly everything else. CNC milling, using a lathe, using a laser cutter, as we're doing. All of those takes a larger piece of work and then cuts away at it to manufacture the final piece. So the thing to understand, right, is when you have CAD, right, this piece, as far as the computer is concerned, is exactly 70 millimeters or whatever, like on the dot, zeros all the way to infinity. And that's not real life, right? So in CAD, if you imagine that this dotted line is sort of the imaginary line that CAD gives you, right? If I were to 3D print this line, when we actually have material, there's going to be material that looks like this. It'll be as small as the 3D printer, whatever we're doing, can make it, but it's going to be larger than the imaginary line that CAD is giving us, right? So to put that in terms of, like, if I have a piece like this that I'm 3D printing, and then inside of this piece, I have a hole. This is the imaginary line of CAD where the hole is. When I 3D print it, the actual line is going to be here. And so this hole is ever so slightly smaller than what the hole is in CAD, right? Obviously, I'm zooming in here, and like you're looking at it like exaggerated, but that's the concept, right?
The outer edge is larger.
Yeah, the outer edge, if this solid line was the imaginary line, then the real line would be out here, larger than the piece, because this is additive manufacturing. If we do the same thing, I'll do it correctly this time, maybe line around. With subtractive manufacturing, so these are the imaginary lines of the CAD, right? When you actually cut, the actual lines are going to be larger than the imaginary line. And on this side, it'll be like this. And the reason is because, moving over here, if I have a block like this and I laser cut through it, right? The laser is removing a section of material that actually has width. It's not cutting these pieces in two and just this plus this is the full width. There's a section of material that gets removed that is in ash, basically. So when you're using laser cutting, your holes end up being bigger than what you had in CAD. And because we use precision wood that is 5 millimeters to a very high degree, if you make your hole 5 millimeters and then you cut it, the hole is actually ever so slightly larger than 5 millimeters, and it will fit perfectly fine into the 5 millimeter thick wood. So because we do laser cutting in wood, you do not have to offset anything. You can just make your holes exactly 5 millimeters using the combine tool, and it will assemble correctly. That being said, if you literally took the exact same hovercraft design and had all of the pieces 3D printed instead, none of them would fit. You would actually have to go in and manually add offsets.
Which, yeah, that gets us to the offset tool. If you were creating a piece that needed to be 3D printed, which you may actually have to do for your hovercrafts or whatnot, there's the, I don't know why I did that. There's the offset actual tool in here. So you'll go to offset face, and then you can actually select, like, let's say there's a 3D printed piece going into that hole, or that was a 3D printed piece. You can actually select faces and then offset them by however much, so you're like 0.2 millimeters or whatever to account for the 3D printer. So you can actually offset things.
Yep. But for any pieces that are just wood to wood, which should be the majority of your pieces, you can just use direct dimensions because we're using subtractive manufacturing. So yeah, we talk more about manufacturing methods next time, but you asked anyway, so I thought I'd bring it up. Any questions about that? Awesome. Okay. So now we're gonna get started. Very rough because we only have about 30 minutes left, a little over 30 minutes, on design. Where are you going?
I'm gonna pull up the,
Oh, yeah. So, so this is going to be your place to start if you want to pull up the manual and start going through or just reading. It's not really like an instruction so much as it is, you read it and then follow what applies to your design. Hopefully you guys already have some basic drawings from last meeting of what you're thinking about for your hovercraft. So start realizing that into CAD, even if it's just the base plate. If you guys can at least draw out your base plate and extrude that, fully constrain everything today, that is a great starting point. So we'll give you guys some time to do that now, and then just like last time, Keith and I will start walking around and helping you guys out, helping you with any questions. If you still have changes to your hovercraft design, first of all, if you made any major changes from last time, tell us that first, so that we can make sure you're not doing anything too stupid. And then we had a Beyblade 2 years ago. I gotta say that.
that's true.
And then get started and let us know when you have questions.
Just go through the design. Can we,